and I forgot. So there's that much. We already did. I just wrote the formula and nothing's happening yet. All right, guys. So we're going to find the derivative. Again, we had to use product rule. So we left r squared. We took the derivative of h, which is 1, but we have to take it with respect to time. So we write dh over dt. We're going to do plus the rest of the product rule. Take the derivative of r squared, which is 2r. We multiply it by that h, and we took the derivative of r with respect to time. Yeah. From this equation, you can see that the rate of change v is related to the rates of change of both h and r. All right, the variables x and y are both differentiable functions of t and are related by the equation y equals x squared plus 3. This one is not hard because they give you the equation. When you get that word problem and you have to set up your own equation, that's when it gets complicated. Everybody understands. So it's not the work part that you're going to do, it's the actual setup to the equation. That's what's crappy, okay? So find dy over dt when x equals 1, given that dx over dt is 2 and x is 1. Sometimes you have to pull out all of these things by yourself, okay? So they're not always just going to give it to you. So on this one, they're just giving everything to you so that you can learn exactly what you need to do. All right, so we're going to start with our equation. Y equals x squared plus 3. You're going to differentiate. So what's the derivative of y? But this time it's going to be dy over dt because we're taking with respect to time. You're going to take the derivative of x squared. What is the derivative of x squared? We took the derivative of x, but we're taking it with respect to time. Right. Because you're taking it with respect to time instead of with x or y. Okay.
Are we going to have corrections on this last one?
Can we focus on this?
Yeah, I'm just stressing out.
Thanks. Remember that x equals 1 and dx over dt equals 2. Yeah.
Why do we put the dx over dt?
Because we're doing it with respect to time and not with respect to x. So if you think about it, if we did it with respect to x, it would be dx over dx, which is 1. So that's why we never wrote it with the x, because we were doing that. Okay, so then when we changed it to y with respect to x, we did dy over dx. But now we're doing it with respect to time. So that t is not in there. If you had a t in the equation, would you have to write dx over dt? No. Everybody understand that? All right. So what is your what is your x? What is your dx dt? So then you just plug it in and solve it out. So dy over dt is 4. So again, the work is not going to be hard. It's setting it up and finding like your x, dx, dt, dy, dt, whatever else it is. Trust me, it's not fun. I literally do not want to hear the complaints. Like I'm telling you now, it is nasty. Does everybody understand? That's why I didn't put it on this test. That's why it's going to be a test on its own. Does everybody understand? Okay. All right. Problem solving with related rates. In the first example, you were given the equation. That related the variables x and y. And we're asked to find the rate of change of y when x equaled 1. So what was the equation that they gave you? Y equals x squared plus 3. Your given rate that they gave you dx over dt is 2 when x was 1. And they ask you to find dy over dt when x was 1. In the remaining examples, you must create a mathematical model from a verbal description. All right, a pebble is dropped into a calm pond, causing ripples in the form of concentric circles. So there's your first thing. It's going to tell you a shape. The radius r of the outer ripple is increasing at a constant rate of 1 foot per second. When the radius is 4 feet, at what rate is the total area of the water, disturbed water, changing? So it gave us something else, the total area. So how do I find the area of a circle? At this point, you should know the area of a circle is pi r squared.
I knew
Okay,
that.
me too.
Oh, so you heard me say it.
I did, but I believe you said.
I swear I'm not kidding. I literally said.
Just my body heard it.
I
All
said.
right, what is your given rate?
1 foot per second.
Good. So what is that rate? What's it for? The radius is changing at a constant rate, increasing. What if it said decreasing? Maybe negative ones. Everybody understand that? So the radius r of the outer ripple is at a constant rate of 1 foot per second. So the way we write that is the rate of the radius over dt with respect to time. dr dt is 1. And then in that last sentence, what did I ask you to do? Find the rate of what? The rate of the total area. So how would I write the rate of the total area? dA over dt. And what other information did they give us in there? When what is? The radius or r is 4. Very good. So now it's just doing the work. So there's where the equation came from, the rate that they gave you, and then what we're trying to look for. Right. So here's our formula. Remember, pi is a constant, so don't get lost in that. Derivative of a. But we got to write dA over dt. That's what we're looking for. How do I find the derivative of pi r squared? Remember, the pi stays. And then when I take the derivative of r, what do I have to write? Very good. You do not have to like clean it up, 2 pi r, whatever. So pi 2 times, what was our r? 4. What was our dr dt? 1. 2 times 4 times 1 is 8 pi. You can leave it just like this, or you can change it to the decimal. What are my units? Because units are going to kill y'all if y'all are not careful. Feet what? Not. What are we looking for? Total what? Area is feet what? Squared. Remember, we're doing it times and times. Okay, so it's 2-dimensional. Feet squared per second. Very good. So good job with feet per second. Just make sure it's squared because it's area. Not too bad, right? Next. Guidelines for solving related rate problems. This is a lot of writing and I apologize. Identify all given quantities and all quantities to be determined. Make a sketch and label all quantities. We're going to write an equation involving the variables whose rates of change either are given or to be determined. Sometimes they don't give them to you. Using the chain rule, implicitly differentiate both sides of the equation with respect to time or t. And then after completing that step 3, after the differentiation, substitute into the resulting equation all known values for the variables and their rates of change. Then solve for the required rate of change. So in the end, you want to make sure you have everything except for that one rate of change you're looking for. So we plugged in for everything except for dA over dt on the last one. Very good.
I don't have COVID, I just got aroused.
Sure. That's what they all say. That's I don't want to think like you anymore, Sammy.
He's always saying he's saying stuff, but ain't nobody else here.
I heard him say that. We said the same thing.
No, when he answers stuff.
He is really quiet when he answers
He
because
said, "Sorry, I knew that
he's
when I said it."
scared he's gonna miss it. Sydney, put your phone up. Sydney, put your phone up. All right, the table below lists examples of mathematical models involving rates of change. For instance, the rate of change in the first example is the velocity of the car. So it says the velocity of a car after traveling for 1 hour is 50 miles per hour. So what would our variable be? We're going to say x equals what? No, that's your velocity. What is x?
Miles per hour.
Miles per hour is definitely your rate. X is going to be your distance traveled. Then your rate of dx over dt is 50. Guys, please stop talking. Miles per hour. When your time equals 1. Why? You want to find out the velocity after traveling for 1 hour? We have 50 miles per hour. What's the one thing that we don't know is how far we traveled. That's why X is your distance traveled. So what do we not know? All right, look at the next one. Water is being pumped into a swimming pool at a rate of 10 cubic meters per hour. If it's 10 cubic meters per hour, we're talking about water in a pool. What are we talking about? Volume. V is our volume. Of water in the pool. You can write in pool if you want to, that's fine. Say it one more time. This one doesn't give you a time, does it? Right. So That time can be variable at any point. What we don't know in the end is the volume. Okay, so then what's your rate? Your dV over dt. Ten cubic meters per hour. It might be easier to do your rate first. I don't know. We got to have the dV over dt because we're looking, what is the 10 meters cubed per hour pertaining to? It's pertaining to the volume. So we're taking the rate of the volume. This one, what is this 50 miles per hour relating to? It's relating to the distance traveled. So that's what it's based off of. All right. A gear is revolving at a rate of 25 revolutions per minute. One revolution equals 2 pi radians. This one's a little bit harder. If we're revolving, what are we using? Circles. Okay. What do we use inside circles, like inside the unit circle? What? Radians go with what? What can I change radians to? And degrees are measures of. If we have 30 degrees, what is that? Angle. An angle. We call angles theta. Very good. Okay, I said it was harder. Theta is the angle of revolution. The rate of theta with respect to time. It says 25 revolutions per minute, and one revolution is 2 pi radians. So how would I figure that out? It will be. I'm going to write it out though. Very good. Per minute. But yes, if you put 50 pi on there, that would be the same answer. That's perfect.
Is this stuff that was visual? Is there easier stuff in Calc?
Do you think that they start with the hard stuff and get easier as you go?
Yes. I mean, that would know.
Then what do we do next? Applications of derivatives, and then I think after that we do integrals, and integrals are reverse derivatives. So once you learn derivatives, it's just like doing the opposite, but it's not too bad. I don't hate integrals; they're just not my favorite.
Wait, so is that what it is? The derivative and then subtract the You're taking derivative pretty fast.
It's complicated. All right, a population of bacteria is increasing at a rate of 2,000 per hour. It's not like volume or anything like that, right? Not revolutions. So we're just going to use X for this. What is our rate? 2,000 bacteria per hour. So what would our X be? Think about it, dx over dt. X over T, the number is the population of bacteria. That's why I said it might be easier to think about it as the rate before you give the other one. It doesn't matter though. All right, y'all ready? These are not bad. They get worse. Girl, it ain't even close to bro. All right. Air is being pumped into a spherical balloon at the rate of 4.5 cubic feet per minute. Find this rate of change of the radius when the radius is 2 feet. So what's your given rate? 4.5 cubic feet per minute. I'm going to write that over here. which is also 9/2. What is that though? Think about it, air is being pumped into a spherical balloon. So what is that a rate of? And it's feet cubed. Volume. Why is it cubed? Volume, think about it in box form, length times width times height. There's 3 measures that you're working on. Yes, ma'am.
Okay, so like where you wrote per minute, if I wrote cubic feet per minute, would that also?
Yeah. So we're talking about volume with respect to time. What they ask us to find. Yeah, it's always going to be a rate of change of what? The radius. So how would I write that? dr/dt. But they put a little more with that. What's the question? Find the rate of change. And that's what we're going to write. When r equals 2. So then your given rate, dv/dt, tells you that we're working with volume. So I don't know why there's so much space here. That's all we need to write on those first 2. Is everybody good with that? Okay. So get on to the equation. What is the volume that I'm going to use? See, do we know this formula, the volume of a sphere? Well, it's not right. 4/3 pi r cubed. So surface area is 4 pi r squared, but when we talk about the third dimension, put the 2 3s. So that's how I remember it. So when we talk about volume, it's 4/3 and it's always cubic. Okay. All right. Now what do I need to do? Derivative. So the first one, what's the derivative of v? Guys, I would suggest you not talk and pay attention. I keep seeing the back of people's heads. Keep seeing phones out. Remember that pi goes with that 4/3. Pi goes with that 4/3. So it's just a regular constant. So we're going to pull it out. What's the derivative of r cubed? 3r squared. And what do I have to write with that? dr/dt. What do I do once I find the derivative? And there's a couple things that I can do before that. I can go ahead and reduce this. How could I reduce this? There's only one thing I can do. 3s. There's one on top and one on bottom, right? So this is 4 pi r squared dr/dt. Do I know what r is? Do I know what dr/dt is? Do I know what dr/dt is? No. Do I know what dv/dt is? Yeah. I'm gonna write it as 9/2, so you can write 4.5. That's fine. And then I'm looking for dr/dt. Right. I have 9/2 equals 16 pi dr/dt. 2 squared is 4 times 4 is 16 pi. How do I solve for dr/dt? I cannot write. Remember, I don't divide fractions, I flip and multiply. So 9/2 times 1/16 pi gives us 9/32 pi. Again, you could have done all decimals, it wouldn't have mattered. And we get 9/32 pi. 0.895. Guys, make sure you put that in correctly. You see how I had to put it in? Is everybody good? So I screwed it up the first time. If you do alpha y equals, it's not going to matter. I was just too lazy to hit alpha y equals. And then what are our units here? And be careful because it's the rate of the radius. It's not the rate of the volume. So there should not be any cubes. What's our unit of measure? But we're not cubic because we're not doing the volume. We're just doing the rate of the radius. Feet per read minute. You guys have got to start putting your units on there. This is important in this section. All right. In the last example, note that the volume is increasing. At a constant rate, but the radius is increasing. Sorry, it's a little line. At a variable rate. Just because two rates are related doesn't mean that they are proportional. In this particular case, the radius is growing more and more slowly as t increases. You guys can think about that like when you're blowing up a balloon, when you first start, it gets real big, real fast, and then it gets slower and slower as you blow it up. Okay. All right, you ready? An airplane is flying on a flight path that will take it directly over a radar tracking station as shown below. The distance S is decreasing at a rate of 400 miles per hour when S is 10 miles. What is the speed of the plane? What is the speed of the plane? So the first thing we're going to do is find our equation. Down here at the bottom, just to get it out of the way, I'm going to do our given rate and what we're supposed to find. I don't care which one you do first. This will help you start your problems, all of your problems. So what was the given rate that they gave you? And how do I write that? What's it equal to?
Equals -400.
It is negative 400. Why is it negative? It's decreasing. I was going to talk about that in a second. Very good. But what do I set it equal to? What is the little fraction that I got to put in front with all the variables? ds over dt. Why is it ds? Because it says that s, the distance s, is negative 400. And it does say when s is 10. What are we trying to find? So this one's really kind of confusing because it uses s for distance. So what can we use for speed? X. We're going to find dx over dt. You don't have to on this because it's not part of your answer. The only place that you need to put your units is on your answer when you finish. So it doesn't matter if you don't have it anywhere else. Okay. So then when S is 10, again, we used X because X is up here. That's a good one to use. That's why they used it. But do we know anything else? We're going to talk about that in a minute. What is 6? Okay, we're going to talk about it in a minute. What equation would I have? What am I looking for? We said find dx over dt, right? So what do I do with this mess right here? How do I set up an equation with it? What do you see? What kind of triangle? And it surely would be a squared plus b squared equals c squared. Is everybody okay with that? So when I see that right triangle, I'm definitely going to do that. So it would be x squared plus 6 squared equals s squared. Make sure that you put it in the correct order. The x and the 6 are interchangeable. The s has to be on the outside. All right. Now what do? Say it again. I'm going to go ahead and rewrite this so that I can remind myself that that 6 squared is just a constant. So what's the derivative of x squared? And I need to write. What happens to the 36? S squared. Perfect. And then from here, what do? Guys, you don't have to do any of the work till the very end. So if it's too much to see dx and dt and ds and dt and try to get it separate, go ahead and plug in. Everybody understand that? Go ahead and plug in. And then the only thing that I should have left is what? What am I solving for? Dx over dt. That's what I'm solving for. So the only thing that I should have left in my formula as a variable would be dx over dt. So let's start here. I have an x. What is x? I can't have that x. I only need dx dt. No, negative 400 is ds over dt. X is right here. Think through it. Oh, no, don't think too hard. Okay, so we do know that s equals 10. Say it again. Go ahead and do the Pythagorean theorem. Yeah, Sammy's smart today. Something's happening. So, I'm just kidding. So I can do Pythagorean theorem because I know that s is 10 to be able to find out what x is. So how do I do that? Because I can do that straight in my calculator. What am I going to do? Here's my formula. X squared plus 6 squared equals s squared. I know s is, and I'm going to subtract 6 squared. And then what am I going to do? Square root, which I already knew. I didn't have to do it in my calculator, but it is. Oh, so down here, x is 8. I need to find dx over dt. I have 2, what was it, s? 10, and ds dt is negative 400. Make sure that you have the negative on there, otherwise it's messing up your answer. 2 times 8 is 16 dx over dt. 2 times 10 times negative 400 is negative 8,000. And then how do I solve? So maybe it makes it a little easier to do if you just go ahead and plug in and then solve for dx dt rather than trying to solve for dx dt and then plug in. Gives you negative 500. What are my units? Miles per hour. What is the speed of the plane? Why don't I use the negative? Right. What's the negative telling you? That you're getting closer to your distance. You're getting closer to your place. That was an easy one. Next, just kidding. All right. Find the rate of change in the angle of elevation. Anytime you see angle of elevation, you better know you're going to use trig functions. Okay. Angle of elevation. Calm down. Of the camera, show below. It should say shown below at 10 seconds after liftoff. This is shown. Need to fix it. All right. They give you some information in this formula, rising vertically according to the position equation, S equals 50t squared. What is your given rate? They give it to you. Hold on. I hear somebody saying something, but I don't have any idea what you're saying. Too quiet. Let's start with the find for just a minute, and then we'll go from there. What are we trying to find? The rate of change of the angle. What do we use for angles? So d theta over dt. When, what do we know? Is it x? No, it is 10 seconds, so that is t for time. All right. Can we figure out what S is? Think about everything they gave you, and it's up here on the screen. How? Nope. Where? Where? Yeah, here. It tells us S equals 52 squared. Is everybody good? So I'm going to start with that. That gives us 5,000. And I'm going to write that down there with the find part. Okay. And again, that formula came from right here. S equals 50t squared. All right, so find the rate of change of the angle. Do I have a formula that will help me with d theta over dt? Where did they get that formula from? That's not the hypotenuse. Everybody understand that? That's not the hypotenuse. So what two sides do you have compared to the angle? You have the opposite and the adjacent. Tan is opposite over adjacent. So they're actually giving you the formula. If they don't give you that, just make sure you understand that typically angle of elevation or angle of depression is going to be tan because they'll give you the opposite and the adjacent. All right, so our formula, tan theta equals S over 2,000. I'm going to change it up just a little bit. So you're looking at it a little different. Tan theta equals 1 over 2,000 S. What do we do to this? What do we got to do to this before we plug in? Derivative, and then yes, we're going to plug in. So what's the derivative of tan theta? Secant squared theta. Sorry, what do we got to put when we take the derivative? Yeah, we took the derivative of theta, so d theta over dt. 1 over 2,000 is just going to stay. What's the derivative of s? But we write dx over dt. They do a lot of work here. I'm going to change it up a little bit and see if I can do it a little different. What do we know? I'm not going to change it up. What is secant? So it's 1 over cosine. So secant squared would be How do I get d theta dt by itself? I'm not going to divide this one. You can divide by 1 over cosine squared theta, but you could just what? You could just multiply by cosine squared theta. So d theta over dt equals cosine squared theta 1 over 2000 ds over dt. All right. Well, what is cosine on a regular like triangle over there? Because I want d theta over dt. I don't want any other, like I know what ds over dt is, right? Do I know what that is? That's the thing we didn't find, right? What does ds over dt represent? When do I write that? When I take the derivative of what? S. Here's S. What is the derivative of S? Everybody see that? So they did give that to you. You just have to pull it out for yourself. That's where it starts getting complicated. If they're not handing you everything, you got to figure out where it comes from. So my problem was I didn't know ds dt, and I definitely need to solve for it. So how would I figure it out? Well, what is the derivative of S? Where is it at in this problem? So now the other thing that I need to fix is this cosine squared theta. Well, the only way I can make it values is to use this triangle. So what is your cosine ratio when you're talking about a right triangle? Okay, so I have adjacent because our adjacent is what? 2000, but I don't have our hypotenuse. So how do I figure out our hypotenuse? Pythagorean theorem. So I'm going to write this up here. Cosine equals adjacent over hypotenuse. I know that my adjacent is 2000. Do I know F's? What was S? So I know that this is 5,000. So what would I do to get my hypotenuse? So what would I do? 2,000 squared plus 5,000 squared, and I'm gonna take the square root, right? I can do all that at one time. 5,000 squared, 2,000 squared gives me, is it okay that I have a crazy decimal? Yes, I might try to put it in fraction form. It's not gonna work, so I'm gonna leave it alone. How many decimals should I round? So 1648, that's what I'm gonna leave it as. So down here, it's cosine squared theta. Don't forget that, cosine squared theta. So 2,000 over 5385.1648 squared. 1 over 2,000. And then what was ds dt? $100. And what was t? Okay, so this, just to remind you, was 100t and t was equal to 10. Now we can just put it in our calculator. And again, I would do alpha y equals to do all of them. 2,5385.1648. That should be squared. Parenthesis 1 over 2,000. And then 100 times 10. And we get Your actual answer, if you don't round, is going to be 2/29. So like if I kept it as the square root of blah, blah, whatever. So look at your rounding. My answer was 0.6897. This one is 0.06897. So if we're going those 4 decimal places, we're going to be fine. What are my units? It's d theta over dt. Theta is in radians per, what was our time? Seconds. All right, one more. It takes up my whole paper, just to let y'all know. Okay, so it does need its own space. All right. The velocity of a piston in the engine shown below, a 7-inch connecting rod is fastened to a crank of radius 3 inches. The crankshaft rotates counterclockwise at a constant rate of 200 revolutions per minute. Find the velocity of the piston when theta equals pi over 3. First thing I want you to notice is I see a triangle, yes, but is a right triangle. Okay, so can we use Pythagorean theorem? We'll talk about this. So first thing, what is your given rate? Uh-huh. 200 revolutions per minute. Almost. It's 200 revolutions per minute, but a revolution is how far? Who yelled that out? Right here. What'd you say? 2 pi. Remember the other one when we had, was it the 25 times 2 pi? Anytime you're talking about revolutions, you got to count how many there are. So it's 200 revolutions at 2 pi. So your d theta over dt is going to be 200 times 2 pi or 400 pi. Again, why the 2 pi? Because that's one full rotation. All right, so that's our given rate. What are we trying to find? When theta is equal to pi over 3. So what are we going to use? Look at your variables that you have on your, especially on your triangle. We already used theta, so which one are we going to use? So dx over dt. And we said when theta equals pi over 3. Anybody remember how to solve a triangle? It's not a right triangle.
Mainly like the angle.
It's close. Law of sines or cosines. Law of sines or cosines. And it just depends on what you have. So on this one, we're going to use the law of cosines. I think these are in your book cover as well. So check out the law of sines as well. Okay. This is a math 2 equation. So it's been a while. And typically if you, I don't know who did. I don't know. I hope y'all all took math 2 honors, but if you only took regular, they don't even put it in the curriculum for regular. Okay. So if you took regular, then you wouldn't have had it. So use law of cosines, and that says that b squared equals a squared plus c squared minus 2ac cosine theta. Right. Your side across from theta is your b. So 7 is going to be b. A is the other side that you give So that's your 3. And C is still like your hypotenuse, okay? So we're gonna do x squared for C squared. Minus 2 times A is 3. C is x cosine theta. I'm gonna clean this equation up. 49 equals 9 plus x squared minus 6x cosine theta. And this is the equation that you're going to derive. I'm going to derive every part of it, write it down, even the constants, just so it's there and it's keeping that space. So what's your derivative of 49? 0. The derivative of 9. Derivative of x squared. And I need to write dx over dt. What do I have to do on this one? Yeah, product rule, but I'm going to take that 6 out before I do it. So I'm going to take that 6 out because it's not really part of it. Take the derivative of the first. What's the derivative of x? But I'm going to have to write. So it'll be cosine theta dx dt because I'm not going to take the derivative of the second. Plus what's your derivative of cosine? Negative sine theta. But I took the derivative of theta. Again, I'm going to clean this up. 2x dx over dt. You can multiply that negative 6 back in now. Sorry, I thought I wrote it. I'm sorry. Thank you. 6 cosine theta dx over dt. It's a negative times a negative, which makes a positive 6x sine theta d theta over dt. Thanks, KP. Appreciate that. It's going to be a lot of work to try to solve it for, it's not a lot of work, but it's enough to solve for d theta over dt. So you guys can just plug in from here. Do we have x? So that's the first thing we need to plug in, right? How could I find x? Because I definitely need that. Any equation that I see on there, there's only one equation I've got, that I could use to solve for x. Yeah, I already put values in that though, right? Everybody see where did I put values in? I have the 49 plus 9 plus x squared. Everybody see that? I'm going to go back up one. Well, I can stay down here. What's your theta? Okay, so I'm going to go there. So this is a side note. So we'll continue this in a minute. We need to solve for x. Before I plug in 49 equals 9 plus x squared minus 6x cosine theta was pi over 3. Cosine pi over 3 is 1/2. You can put that in your calculator and it'll bring it up. Make sure it's in radian mode though. Remember I told you pre-cal we're switching back and forth, so they may have it in degree mode. Right. Half of 6x is 3x. I have an x squared and an x, so I know I'm going to have to factor. So I'm going to move the 49 over. I'm going to subtract 49 but then I need to write it in order. So x squared minus 3x, 9 minus 49 is negative 40. Do I have factors of negative 40 that add to negative 3? When I solve this, what are my two answers? Negative 5 and a positive 8. What did x represent? Where was x at? It's the side of the triangle, right? So it's a measurement. So can I have a negative 5 measurement? No, so we're not using that one. We're using that x is 8. So now I can go back to my equation and start plugging in. 0 equals 2 times 8. What was dx over dt? That's what we're looking for, right? Okay. Don't stress out. Minus 6. Cosine, what was theta? There's dx dt again. We're looking for that. Plus 6, what's your x? 8. Sine theta is pi over 3. What was your d theta over d pi? I mean, d theta over dt? 400 pi. I'm going to go ahead and put this in my calculator. So 6 times 8 sine pi over 3, 400 pi gives me 52,236. It's fine. That's a good number. Okay. So I'm going to rewrite this. 16 dx over dt minus cosine 6 cosine pi over 3 dx over dt plus 52237.4217. I need to get the dx dt's by themselves, so I'm going to move this 52,000 to the other side, and I'm going to factor out that dx dt. So I'm going to subtract 52,237.4217. And I'm going to factor out dx over dt. I can put this in my calculator, this 16 minus 6 cosine pi over 3, and I get 13. And then how do I solve? It's going to come out positive because I have the positive in there, but it should be a negative. So divide by 13. And I get that dx over dt equals negative 4018.2632. And then what are my measurements? Or my units? Inches per minute. Inches per minute. Why? It says find the velocity of the piston. And that's that 7-inch connecting rod that it's going to talk about, 7 inches. All right. So during advisory today, do y'all have anywhere to go? I don't know. Can you miss it? I'm gonna give you your test back during advisory. That's the only, that's it. That's the last amount of time I can give you. Everybody got it? You'll do your 3-7 homework in class tomorrow.